Good morning, everyone. Let us discuss about improving the readability of decompiler. Myself, Chelikam Gayatri Reddy, and my teammates are Chappidi Teja and Chamirthi Hemant. Introduction. Decompilers are indispensable tools in Android malware analysis and app security auditing. Numerous academic works also employ an Android computer as the first step in a program analysis pipeline. In such settings, decompilation is frequently regarded as solved problem in that it is simply expected that source code can be accurately recovered from an op. On the other hand, it is known that obfuscation can negatively impact the compiler's effectiveness. Therefore, in order to better understand potential failures mode, example automated analysis pipelines having decompilation, it is important to characterize the performance of decompilers on both the begin and malicious apps. To this end, we have performed what it is to the best of our knowledge. The first large scale case study of Android decompilation failure rates. Reverse engineering of binary executables is a critical problem in the computer security domain. On the other hand, malicious parties may recover interpretable source codes from the software products to gain commercial advantages. On the other hand, binary decompilation can be leveraged for the code vulnerability analysis and malware detection. However, the efficiency of binary leverage for code vulnerability analysis and malware detection by finding a good approximate candidate and then fixing it towards perfect code achieves superior performance as compared to baseline approaches. We assess coders' performance with extensive experiments on various benchmarks. Evaluation results show that code achieves an average of 82% program recovery accuracy on unseen binary samples, where the state-of-the-art decompilers yield 0% accuracy. Furthermore, Coda outperforms the sequence-to-sequence model with an attention of by margin of 70% of program accuracy. Our work reveals the vulnerability of binary executables and imposes a new threat to the protection of intellectual property for software development. Literature survey. Decompilation is a fundamental technique in the analysis of malware, enabling analysis to understand the inner workings of malicious code and identify potential vulnerabilities. However, decompiler created code is often complex and challenging to comprehend, embedding the analysis process and slowing down the identification of malicious behavior. To address the challenge, there is a growing body of research focused on improving the readability of decompiled code. Survey of Survey code of refactoring techniques in decompiler tools. Refactoring is a technique used to improve the quality and maintenance of software code by restructuring it without its external behavior in the context of malware analysis. Decompilers are often used to transform binary code into a human readable source code format, allowing security researchers to better understand the behavior of malware. However, compiler generated code can be difficult to read and understand due to the presence of code artifacts such as obfuscation, dead code, and control flow structures. To address this issue, code refactoring techniques can be applied to decompile code to improve its readability and maintainability. Renaming variables and functions, removing dead code, extracting methods, optimizing app loops and conditions, splitting the merging statements. Comparative analysis of existing decompiler tools. Decompiler tools play a crucial role in the analysis of malware by transforming compiled binary code into readable and understandable source code. However, the effectiveness and readability of decompiler tools can be vary significantly based on their features, performance, and capabilities. In this report, we conduct a comprehensive analysis of existing decompiler tools to evaluate the suitability of malware analysis.
Authors often employ various abstraction technology to make the analysis of the code difficult. One common technique used for malware authors is complete their code into machine code, which is default to understand and analyze. Decompilers are tools used to reverse the process, transferring machine comeback in high-level code in easier to understand. However, the decompilated code has lack readability and may contain errors, making it difficult for analysts to understand the behavior of code. The problem, therefore, to prove reliability of decompiler created code, which will accelerate the analysis of malware. The problem arises the limitations of existing decomplexers often reduce code to difficult to read, understand, and analyze. The decompiler generated code may contain uses such as syntax errors, incorrect variable naming, redundant or unnecessary code, which make the challenge to understand the behavior of code. Improving the readability of compiler generation code can significantly enhance the speed and accuracy of malware analysis by improving the quality of decompiled code. Secure research can quickly identify and understand the behavior of malware, allowing them to develop effective migration strategies. Therefore, there is need to develop technologies and use that improve readability of decomparison code to accelerate analysis of malware. Code readability essential human to correctly understand the functionality of code. We conducted several information interviews of malware analytics to identify shortcomings of stage of the art decomposers, the negative impact readability. We can conduct you work through stepping through the restructure malware can produce the X-rays and dream to see the problems to developers which are group design problems into three categories.
In this paper, we made the three main contributions. First, we conclude that the discussion three user survey provided valuable information for research in the area of designing engineering, reverse engineering, and decomposition. We published the survey result, allowing other researching to use them in three ways. As a guide, using performance of decompiled output and of the code in general, insights into the limitations of the current for the user representation. As a starting point of the new research, a key finding of our survey is that majority of participants do not necessarily for decomposition, providing output as close as possible to the structure implements by the assembly as long as it provides the reliability. Instant to the help human analysis, it can be highly benefit to the allowing the more flexible output generation while maintaining semantic equations. Because reliability seems to the highly subjective analysis can be made from the high level representation influenced by the decompiler parameters. Thank you.